Does anybody have any questions? Okay, so just so you know, we are going to be making stuff again today. Make sure you have your kit available. We're going to need the foam cup, the foam plate, the aluminum plate, one of the straws that you opened up already, the thread, the pith ball, the neon bulb, and the fabric. Now, just so you know, people from yesterday were having trouble getting the foam to charge up with the wool or the wool blend that we gave them. And they were having more success using a pet like a dog or a cat. So that's an idea if you want to try that. All right, so we're going to get started with reviewing the sticky tape lab first by doing a class kick. So if you should already have a portfolio account with ClassKick. So all you would need to do is log in, and you should see the ClassKick already sitting there. And this would be the Review Sticky Tape Lab ClassKick. So if you could please go into ClassKick. Now, if you don't have a portfolio account, so you can't log in and see the ClassKick, let us know. We can help you get in. We can get you an account. It takes a few steps, but it's not a big deal. Does anybody have any questions or need any help? So remember, you can try more than once on any particular question that's in the ClassKick. It will tell you when you're right, and then you can move on to the next page. Be sure you find the please move to the next page before you actually move to the next page. One of the pages, excuse me, one of the pages is very long. It goes all the way to the bottom. Please let us know if you have any questions. When you're filling in the words, make sure you get the answer to look exactly like the answer in the word bank. So capitalization, spelling, the answer has to look exactly the same. Do you mind if I use stickers?
No, yeah, go for it. I'll go through after class and markable.
I like stickers.
Positive reinforcement.
Yeah. I think mine's lagging. All right, looks like we're getting close to being done with the class kick. I'd like to thank everybody for doing that. I'm going to go through the answers. I'm just going to pick one of these at random to take a look at. All right, so if you could join us on the meeting again. When you're finished, of course, with the class kick. I'm going to go through why these answers are the right answers, what the reasoning is. All right, so looking at number one, the first page of the class kick, we're given that somebody has drawn the sticky tape diagrams, but has asked us to fill in the details. So we're to draw in, assuming that the tapes start out neutral, what happens when we separate the tapes? How do they become charged? What is our model for why the bottom tape becomes the charge it does and the top tape becomes the charge it does. All right, so there's a few things we need to know here. The material itself is made up of protons and electrons. The protons cannot move. They are quite literally the material. So if you take away a proton, you're actually destroying the material. So the protons never move, not in our problems at least. It's the electrons that move, and we use arrows to indicate the motion of the electrons. Neutral material means for every proton, there's an electron. So the C is wrong because those materials aren't neutral to start with. The top material would be negative and the bottom material would be positive, so that's not neutral. When you separate them, the bottom tape has plastic that was touching the top tape, and the top tape has adhesive that's touching the bottom tape. And it turns out that the adhesive likes, or the plastic of the bottom tape likes the electrons more than the adhesive of the top tape. So the bottom tape's plastic steals electrons from the adhesive of the top tape. So the electrons are going to go from the top tape down to the bottom tape. So A is wrong because it's in the wrong direction. The electrons are going the wrong way. B is in a sense right, except that the bottom tape doesn't seem to have any protons. So, and it's missing any starting electrons that it may have had. So what we're going to be looking for is where there's a transfer of electrons, where the protons don't move, and some of the electrons from the top tape have transferred down to the bottom tape. So that's why D is the best answer. Does anybody have any questions for the first page? All right, I'm going to move on to the next page. This is just so that everybody is clear about the differences between electrons and protons. The protons are stuck in the nucleus and have a positive charge. The electrons are allowed to move and they have a negative charge. They're found in the outer regions of the atom. All right, the next page. Now we've got sticky tape being brought up next to an aluminum foil, and we're to draw the correct model to indicate why the bottom sticky tape would be attracted to aluminum foil and vice versa. So first we need a bottom tape, which means tape with extra electrons stuck to it. Notice that they all have that. So they're all okay as far as using the bottom tape. So now let's look at the aluminum foil. In a metal, the electrons are free to move anywhere. They can go throughout the metal. It's a good conductor of electrons. So this first one would be a metal. This is a good drawing for the model of a metal. The second one isn't. So B would be the model that we use for an insulator, where the electrons can't go too far. They're stuck around their atoms. Now C is wrong because the electrons can move, but the protons can't, and C has the protons moving. That can't happen. The protons stay still. They are stuck in the center, the nucleus of the atom. And also C is wrong because it's an insulator as opposed to a metal or a conductor. D is metal. It's a conductor. However, it has the protons moving, which is not correct. In our model, the protons can't move. So the only one that satisfies being a conductor, having the protons unable to move, and the electrons are the ones that shift away from the bottom tape's electrons, is answer A. Does anybody have any questions on that? Okay, so let us know if you do have a question at some point. We're going to move on, and we're going to look at the next lab now. We're going to introduce the Electrophorus lab. There is another CAMI document for this lab. I'll put the link to the document in the chat. We're going to walk through making the device and charging the device. Does anybody need time before we get started? All right, so I'm going to go over to the demonstration table, and I'll see you over there in a minute. If possible, could you put up, if it's possible? Okay, thank you. Yeah. All right, we're going to get started. First of all, since we're switching to a new mic, can you guys hear me okay on the presentation or the conference mic? Sound check. Okay, thank you. All right, so we're going to get started. This is what the Electrophorus top plate is going to be looking like. We're going to aim to get this as a final product. To start off with, please find your aluminum pie pan. Now yours might have this look to it where the edge is actually raised, and instead of being a pie pan, this is like a to-go container. So for this to work better, if you happen to have gotten one of these, please bend down the edge as if you were sealing up that to-go container. But pan. Find a foam cup, and we're going to tape this down onto the aluminum pie pan to act as an insulating handle. This handle is how you're going to always grab onto the pie pan. The reason is because if you touch the pie pan with your hand, you're going to share electrons with it, and we want to avoid that. So that's why we're giving you a handle. All right, so using tape, I'm going to secure that foam cup onto the aluminum pie pan. It does not matter what type of tape you use. I would not recommend hot glue. The foam cup will not work out with the hot glue. So once you get the handle taped on, you should be able to pick it up. And it should be fairly secure. It doesn't have to be perfect, but it should be fairly secure. All right, next, please find one of the straws from our very first demonstration or investigation. You should already have an unwrapped straw. You'll need a scissors. what we're going to do is put a slit in the end of this straw. So I'm going to squish the end of the straw to sort of flatten it out. It's not going to stay flat, but make it as flat as you can get it. And then we're going to cut the slit the long way down the straw. So using the scissors, cut about a 1/4 inch. You don't have to go too far. But now we've got the straw cut so that there's a slit down the straw. Next, find your thread. You either got a bobbin or thread wrapped around a card. It doesn't matter, it's still thread. Take about 6 to 8 inches of thread, 15-20 centimeters. I'm going to cut that and find a pith ball, which is the small straw wrapped with aluminum. If your pith ball has been squished or it's deformed and it's not looking much like a straw, one thing you can do using a pencil, you can round out that pith ball, and by pressing in with a pencil to round out that pith ball. We're going to tie the pith ball onto the end of the thread. I'm going to use a simple knot, like a granny knot, a box knot. I'm not a Boy Scout, sorry. I wish I knew more about knots. I'm going to do it multiple times, 3-4 times, just to make sure that the knot stays. In video, we would use like a 6 times speed to speed that up. Okay, and then I'm going to cut off that little extra dangly part down to maybe a 1/4 inch or so, a little under a centimeter. So now I've got a pith ball at the end of the string. Go back to the straw and insert that thread in the slit that we cut so that it just hangs there. Going back to the top plate of the Electrophorus that we put the handle on, I'm going to tape the straw such that the pith ball will be right at the right height and at the right distance so that it will bounce off the aluminum plate. Right, so going back to my tape, I'm going to get a fairly long piece of tape for this one. And just tape the straw to the top of the foam cup. Now my pith ball is at a fairly good distance, so I'm going to take care of that extra thread I'm going to wrap it around the end of the straw and then tuck the loose end into the slit to keep it under control. All right, we went a little fast through that. Does anybody have any questions or need any time? Is everybody okay? Does anybody need time? Please give us a little bit of feedback. Can you guys hear us okay? All right, thank you. All right, we're going to move on. I hope everybody is with us. So find the neon bulb. This is in the small parts bag. You might have to search for it, but it is literally a light bulb and it's filled with neon gas. We're going to bend the leads, but please don't bend them yet. I'm going to give you a particular way that I would like you to try to bend them. All right, so we're going to pinch the leads, grabbing onto the light bulb, but pinch onto the wire of the leads. And we're going to bend at where our pinch is. So I'm going to bend both leads to the side. So I end up with the light bulb looking like this. If you try to bend the lead at the glass, it will very likely break off. So you want to bend the leads away from the glass. Okay, now we're going to put another bend on one of the leads. So I'm going to choose this lead. I'm going to pinch it halfway, and then I'm going to bend it to the side. So now it looks like this. Okay, we're going to tape this onto the rim of our top plate Electrophorus. I'm going to take 2 inches, maybe 6 or so centimeters-ish. Find a place on the rim that is away from the pith ball, so maybe a quarter of the way around the rim. I'm going to tape the bent end of the light bulb onto the rim of the Electrophorus aluminum plate. So that it looks something like that. I don't want the other wire to touch the aluminum. I want it to be completely free. Only the bent end is touching the aluminum plate. Now let's go over charging. This is the bottom plate of the Electrophorus. It's the foam plate. We're going to charge it with our cloth. Now you will probably have a cloth of wool blend instead of 100% wool. If you're lucky enough to get one of these, this is 100% wool. If you've got the tan or the dark gray, that's a wool blend. We would recommend using 100% wool if you have it, or a pet like a dog or a cat. That works out really well. If we were in the room, you would actually be using rabbit fur. Now to charge up the plate, you just want to make the wool touch the foam. Right now, the foam likes electrons more than the wool, so the electrons are transferring from wool to the foam plate. But there aren't many, and so there isn't much of an effect. We have to get a large effect. So we're going to aggressively make the wool touch the foam plate so that we roll around those fibers, we get lots of wool touching lots of foam. You might actually hear crackling if you get a good charge, but when it's charged up, the wool will actually stick to the foam. It won't slide off. They're stuck because of the negative foam attracting the positive wool. All right, so I'm going to pull the wool off. To charge up the top plate of the Electrophorus, I'm going to set the aluminum onto the foam. And you'll notice that the aluminum attracts to the foam too. Now I'm going to hold up the plate so that you can see the bulb. I'm going to charge up the plate by touching the wire of the light bulb, and you will hopefully see the light bulb flash. Nope. Now it may flash brightly, you may not see anything, that's okay. You can also try to listen for the spark. Now I'm going to pick the top plate away from the bottom plate and do it again. Touch the wire, and hopefully you see the light bulb light. All right, so that's the construction and use of the Electrophorus. Do you guys have any questions? You guys need any help?
Mute the other microphone.
Does anybody need any help? All right, well, that is the Electrophorus. So we would like you to work through the Electrophorus lab now. You can, if you think you're good, if you have your Electrophorus all put together and you have the CAMI document that you can follow through the lab, it's work time. You don't have to stick around. If you do want to leave, that's fine. We thank you for coming today. So good luck, and we will see you Monday. We'll hold on in case anybody does have questions. So for those planning to leave, thank you. Bye. Have a good weekend.
Yeah, have a good weekend, everyone.